In stats, we started by looking at the difference between cluster random samples and stratified random samples. And I just wanted to give you more ways to see how they're done differently. The wording can be tricky. So we have this problem, skim through it real quick. They have all these equal-sized rectangles, 200 of them, and they sample 20 of those rectangles. They're looking at every tree in those rectangles. I feel like the one of is a little confusing. So, I don't know, I'd reword that, but I would say this is cluster. The fact that they're doing every tree in the rectangle selected is the giveaway that it's cluster and not stratified or SRS. A reason why this method was chosen? Well, think about the alternative. This sounds like a pretty monstrous forest. And if you did an SRS or a stratified, you would have to number every single tree and sample them. This would be a lot of footwork. Like already, this cluster sample is going to be a lot of footwork. But SRS, you could be all over the forest. And then stratified, you're guaranteed to be all over the forest. So if time is an issue, cluster is going to save you a lot of time. And cluster is still random. I guess it also depends on what you're trying to achieve. You know, if you're just trying to get a plain old random sample and you suspect that all the trees in the forest are pretty similar and you're just trying to look at them, then this is great. If you think one part of the forest is worse off than another part of the forest, then maybe you have to do stratified random sampling. It just depends on what you're trying to accomplish. Another example of sampling is right here. They ask, is it an SRS? They have a bunch of engineers, 2,000 males, 500 females, and they tell you up front that they do a stratified random sample. So I think that right away tells you it's not an SRS. They're doing 200 males, 50 females. They're making it proportional because of the different gender-sized group. And they tempt you with this sentence right here. This sounds really similar to the definition of an SRS. All they're doing is they're making it so that women and males can be included in the sample. They're forcing it to be proportional. But this is a different sentence than the definition of SRS. This is not every possible group of, let's see, they chose 250, so 250 from the 2,500. You know, they force equal representation. This is not SRS. Not SRS. This is stratified. I hope that makes sense to you. So two good examples of stratified and cluster. Next, we broke down types of bias. So in our class, we are trying to work towards making inference. So we are trying to infer something about a population from the sample we take. And if our sample is biased, then our conclusion is going to be off. So the first type is undercoverage. In this scenario, I would say it is impossible some to participate. I mean, the typed words are better. I'm just trying to give you another way of looking at it. So if the way you're conducting your sample makes it so that some people group, some part of your population can't participate, then that's undercoverage. I think you already know what non-response is. People refuse to participate. Response, this is involving manipulation. You are manipulating people into believing or doing a certain thing with your wording. Wording is changing the way people feel, maybe creating an emotional response so people respond a certain way. Another form of response bias is measurement bias. And this is if we have a bad ruler and I consistently measure things incorrectly. Then all my measurements are off. That's bias. All right. We looked at an example of bias. We'll do that in the next video. Bye, y'all.